Assalamualaikum and hello to Dr. Amy, Zaira and my fellow friend. Today our group will be present about Chapter 2 Sinusoid. Before that, I would like to present about team member. The first one is Ahmad Hafizuddin bin Muhammad Azman. The second is Mak Ruben bin Justin. The third is Muhammad Haikal bin Mahadi. The fourth is Dini Harid bin Hairul Nizam. The last one is me, Wan Muhammad Nazmi bin Wan Mubarak Sahril. For introduction of sinusoid, sinusoid are basic waveform in electrical and electronic engineering and have application in the most real-world system. Sinusoid have widespread application in alternating current, which is AC system, in which most voltage and current have sinusoidal waveform. A sinusoidal signal changes in smooth and continuous manner over time and has attribute of amplitude, which is maximum level, frequency, which is rate of change per unit time, and phase, which is position of the waveform. The most basic sinusoid are the sine and cosine waveform that can be readily produced by an AC voltage source such as a generator and electronic power supply. Sinusoidal waveforms are more suited for purpose of long distance transmission because of less energy loss. Ensuring components such as resistor, inductor and capacitor react accordingly when dealing with sinusoidal waveform. Therefore, grasp of sinusoid is essential in understanding AC circuit analysis.
Next, my name is Dini Harid bin Hairul Nizam. For this slide, I will explain the operation between sine and cosine using a graphical or Phasor approach. First, the horizontal axis represents the magnitude of cosine, which is cos omega t, while the vertical axis pointing downward represents the magnitude of sine, which is sine omega t. Angles are measured positively in the counterclockwise direction starting from the horizontal axis. Using this diagram, we can easily visualize phase shift between sine and cosine. For example, when we subtract 90 degrees for cosine, it converts into sine. Mathematically, this is expressed as cos omega t minus 90 degree equals sine omega t. Graphically, this means we move 90 degrees clockwise from the cosine axis to obtain the sine value. Next, when we add 180 degrees to a sine function, the sine value becomes inverted. This is written as sine omega t plus 180 degrees equal negative sine omega t. From a graphical perspective, this represents moving halfway around the circle or 180 degrees, which causes the sign of the sine value to reverse. This method is useful because it helps us clearly visualize the relationship between sine and cosine, including phase shift and sign change, rather than relying only on mathematical equation. Finally, this concept is very important in AC circuit analysis and Phasor representation, where understanding phase difference between voltage and current is essential.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hafizuddin bin Muhammad Azman. Now let's take a look the two sinusoids shown below. So for the first waveform is V1t equal to Vm sin omega t, and the second waveform is V2t equal to Vmc omega t plus phi. Both signals have the same amplitude Vm and the same angular frequency omega. The difference between them is the phase angle. From the graph, we can see that V2 reached its zero crossing and peak earlier than V1. This means V2 occurs first in time. Therefore, we say that V2 leads V1 by phi, or equivalently, V1 lags V2 by phi. This concept of phase, lead and lag is important in understanding sinusoid signal in electrical and electronic systems.
So let's move to the next part, which is the application of the sinusoid. So my name is Mark Ruben bin Justin. There are two methods in determining which sinusoid is leading. First method is trigger identities, and the second method is graphical representation. So today I will be explaining about the graphical representation. Firstly, we need to draw the graph as in the animation. For the horizontal axis is for the cosine, and the vertical axis is for the sine, and the degree angle counterclockwise is positive and the clockwise is negative. Next, let's move to the application or the question for sinusoid example. So in order to answer this question, we need to see the question which is V1 is equal to negative cos. So the direction, or we need to place the point on the negative side on the horizontal part for negative cos, which is on the left. So when it says that the angle degree is 50 degrees, so it will be counterclockwise. So the direction is counterclockwise 50 degree, and that is for V1. And the negative 10 is refer to the direction or the length for the V1. Then for V2, the given angle is negative 10 degree, so it will be clockwise. So since it's a positive sign, so it will be on the vertical axis on the bottom part, so it will be clockwise. And we can draw the line for the V2, which is 12. So since 10 and 12 is slightly different, so the 12th line will be longer than the V1. So in order to determine which sinusoid is leading, we need to refer which phase angle, or V1 and V2, which one is closer to the cos omega t, since it's the finishing line. So we can calculate the angle difference. On the differences, V2 is leading V1.
Hi, my name is Muhammad Haikal bin Mahdi. Okay, for the conclusion, sinusoids are very important in electrical and electronic engineering, especially when analyzing and working with alternating current AC. The reason why sinusoids are a very good representation for AC is that they are smooth, continuous, and periodic, which result in a more realistic representation, since AC are, in fact, smooth, continuous, and periodic waves. Knowledge of the basic characteristic of a sinusoid waveform, such as amplitude, frequency, phase, and waveform, enable engineers to correctly determine the behavior of different components of a circuit, including resistive components, inductive components, and capacitive components. Identifying these factors plays a significant role in determining the critical elements of a circuit, such as phase, impedance, and power associated with the component. Moreover, the knowledge of sinusoids lays the foundation for more complex subjects related to electrical engineering, which include analysis of AC circuits, signal processing, and communication system. In fact, knowledge of sinusoids will help engineers build efficient, stable, as well as more reliable electrical systems. In short, knowledge of sinusoids is very important not only for academic but also for practical applications in the generation, transmission, or communication field. That's all for me. Thank you.